On November 19, 2025, NASA promised the world a major update on a mysterious visitor from deep space, an interstellar object named 3I Atlas. Instead, they kept repeating just one message: it was just a comet. 20 different spacecraft observed this object, but the public was only shown a few blurry, low-detail images. The official broadcast began under a global spotlight of anticipation. For weeks, NASA's promotional campaign had built up the moment, promising scientific clarity, a major update on the interstellar visitor 3I Atlas, complete with new images and findings from a worldwide fleet of telescopes and spacecraft. The date, November 19, 2025, was circled on calendars in the scientific community and among curious minds everywhere. People tuned in expecting revelations, drawn in by headlines describing a rare, maybe even historic event. But as the stream opened, the tone felt anything but celebratory. NASA's hosts, speaking from a sleek, polished studio, chose their words with extreme care. Instead of diving into discoveries, they immediately addressed the rumor mill churning online. Before a single piece of data was shared, the audience was told directly there was no evidence of anything artificial, nothing beyond the ordinary. The phrase, "just a comet," was woven into the opening remarks, repeated with a calm, almost forced insistence. The effect was immediate. The atmosphere, instead of being one of open excitement, felt heavy and deliberate. NASA's representatives spoke at length about the challenges of studying objects from outside our solar system. They reminded viewers that interstellar comets are rare, but insisted that 3I Atlas fit the textbook profile perfectly. Every statement seemed rehearsed, as if they were anticipating questions that might go too far. The hosts leaned on established science. Comets shed dust, comets have eccentric orbits, comets come and go, all while steering the conversation away from any speculation. This defensive posture stood in stark contrast to the event's promotional buildup. Instead of showcasing new discoveries, the entire stream seemed to be about managing expectations. The promise of a data-rich, transparent update was quickly replaced by a wall of careful language. The restraint in the room was unmistakable. Every answer felt filtered, every fact buffered by caveats. In that first hour, it became clear that what would not be said might matter just as much as anything that was revealed. Nearly 20 spacecraft and observatories were tasked with watching 3I Atlas as it swept through our solar system. Hubble, James Webb, Lucy, Psyche, Maven, the Mars Reconnaissance Orbiter, and more. Each mission was called out by name in NASA's official rundown of the campaign. From orbiters circling Mars to telescopes perched on mountaintops in Chile and Hawaii, the scale of the effort was described as unprecedented. Yet, as the livestream unfolded, the promised flood of imagery never arrived. Instead, viewers were shown a sparse handful of faint, distant frames, mostly from Hubble and briefly from the James Webb Space Telescope. These images were low in detail, their subjects little more than dim smudges against a black backdrop. There was no gallery of raw frames, no high-resolution composites, no side-by-side comparisons from the different missions. The vast majority of the campaign's visual record remained unseen. NASA officials addressed the absence of material with a steady rhythm of explanations. One presenter noted that some data was still being downlinked, referring to the time lag between a spacecraft capturing data and it arriving back on Earth. Another cited the need for careful calibration, saying the instruments were pushed beyond their normal design limits, so the results required extra processing. There were reminders about viewing angles, the risk of optical artifacts, and the technical challenges of imaging a faint, fast-moving target. Each justification sounded plausible on its own, but as the list grew longer, the effect became harder to ignore. The emphasis wasn't on what the data might reveal, but on why it couldn't be shown yet. Official phrasing became familiar: pending full calibration, still under review by the science team, awaiting validation, and results will be published after peer review. For some missions, like Lucy and Psyche, the stream only offered a vague promise of future updates. For others, such as Maven and the Mars Reconnaissance Orbiter, the only public evidence of their participation was their mention in the roster. No images, no spectra, not even a timeline for release. Meanwhile, the Virtual Telescope project in Italy, operating independently, streamed its own live views of 3I Atlas before and during NASA's event. Their images, though technically limited, were shared openly and without delay. The contrast was striking. By the end of the broadcast, the gap between the massive scale of the campaign and the meager public release was impossible to miss. Nearly 20 missions, yet only a handful of images. The audience was left with a long list of reasons for what was missing, but very little to see for themselves. The story of 3I Atlas, at least for now, was defined as much by what remained hidden as by what was revealed. During the broadcast, the few moments when NASA actually addressed scientific findings stood out for their brevity. One presenter mentioned that 3I Atlas carried an unusually high ratio of carbon dioxide, higher than any comet ever measured in our solar system. The statement hung in the air for a moment, then faded as the presenters returned to reminders about calibration and the need for more analysis. The exchange felt incredibly brief. Moments later, another anomaly surfaced. The comet's nickel content was described as excessive compared to its iron, a pattern not seen in previous interstellar visitors or typical comets. Again, the detail was acknowledged, then quietly set aside. The observation felt significant, but it was not pursued. A third clue appeared in a single sentence about dust polarization. The light reflected from the coma of 3I Atlas showed a pattern that did not match known solar system comets. Polarization is like a fingerprint, and its deviation can hint at unfamiliar chemistry or structure. But this potential marker of an alien origin was left completely unexplored as the discussion returned to generalities about comet dust. The word polarization was mentioned and then just dropped. The live stream also included a fleeting reference to the age of the comet's home system. Preliminary data implied 3I Atlas could have formed in a star system older than our Sun, a detail that would make it a messenger from a time before our solar system even existed. The idea flashed by unexamined as the conversation returned to safe ground. The powerful image of a messenger from the distant past was suggested and then immediately moved past. Finally, a subtle but measurable acceleration in the comet's path was mentioned. Non-gravitational forces, like jets of gas or dust, can nudge a comet, but the specifics here were left vague. In the space between these facts and their non-explanations, the sense of something unresolved grew stronger. Questions about the true nature of 3IATLS landed with a thud, met by a practiced rhythm of deferral. The word uncertain became a shield, repeated whenever a question threatened to break the surface. The word ordinary surfaced again and again, as if repetition alone could settle the matter. Even when anomalies were acknowledged, the response was to assure viewers that such things can happen with comets, that more data would be needed, and that conclusions would have to wait. Timelines slipped into the indefinite future. The longer the Q&A went on, the more it felt like the real story was in the choreography of what could not be said. The audience, primed for discovery, was left to wonder if the silence itself was the most telling answer of all. Today, unanswered questions shape our trust in those who watch the skies for us. Sometimes the silence tells us more than any official answer ever could. Thanks for watching, and if you want to keep exploring the big questions, make sure to follow for more.